Welcome, ladies and gentlemen. May I have your attention, please? Thank you. Let's go ahead and get started with our graphing. We're going to continue with our transformations of the sine and cosine functions. Today we're going to start with an equation and construct a graph. And we're also going to start with a graph and work backwards and construct the equation. Just like your transform sine and cosine curves practice packet will be turning in a little bit. All right, so can we find an equation for the given graph? Well, we can. We have to consider some key features like if we're starting with a max or a min in relation to the center line, then we know we'll use a cosine curve. If we're starting with an intercept of the center line, then we know we'll use a sine curve. And so everybody take a look at this first one. On the y-axis, right? On the y-axis, my initial value. Does this blue function start at a max or min in relation to the center line, or does it start at an intercept of the center line? Jared? It starts at a max. And so which function is this going to be transformed? A sine or a cosine? Aaron? Cosine. A cosine, good. So we know this blue one's going to be a cosine. To figure out, right, to figure out the parameters then that I'll go in my cosine equation, y equals a times the cosine of b x close angle input plus d, I'll have to consider things like where's the center line? What's the period? What's the amplitude or wave height, the distance that separates max and min back to the center line? And so I think the best way to approach this then is to draw in that center line right away and figure out where that is. So I'm going to go ahead and take my line tool, and we want to make a center line, right, that divides the graph into top and bottom equal half. So it looks to me like, where would my center line be? So half, like down to, so right about, yes? So you guys getting y equals 1 as the equation of my center line? Raise your hand if you get y equals 1 for the center line. Great, that's going to be d, thank you, that's going to be d in my equation. Now to figure out the amplitude, I can consider the distance that separates the max back to the center line. This vertical wave height here is my amplitude A, or the distance that separates the minimum back up to the center line. In either case, I get 3. So it looks like A is going to be 3. D is going to be y equals 1. So D is going to be 1. And then the only thing that remains is my period. To help with that, I can consider my window. My window, we were told, went from x min negative 360 to positive 720. So this must be 720, 360. So let's see how long it takes to get one full cycle in my cosine graph. I can do any key point and see how long it takes to get back to the same key point. I'm going to choose this maximum because that'll be easy to find the next maximum. That occurs in, gosh, 720 degrees. So the last thing I need is the value of b. And to get b, I can simply take my normal period of my parent function is 360 degrees and divided by my observed period. This took 720 degrees to complete one full cycle. So my speed factor or frequency, my value of b is 360 divided by 720 is 1/2. Let's put it all together and see if we can generate the equation. Ready? Y equals amplitude A was 3. Cosine of angle input was 1/2 times x, close angle, and then plus 1. Go ahead and take a look. Raise your hand here. Y equals 3 cosine of 1/2 x plus 1. Okay, so let's go ahead and go back. Raise your hand if you had just the amplitude of 3. So I need to know just about amplitude. See how you're doing. Amplitude of 3. Raise your hand if you had center line of 1. Center line of 1, that's good. Let's take a look at the speed factor. That's the trickiest part. So first, I need to know who had period of 720. You can get that from the graph, 720. Great. Then the thing we're missing is being able to figure out b. So to find b, the speed factor or frequency relative to the parent function, I take the normal period, 360 degrees, and divide it by my observed period. After reducing that, that'll give me my speed factor b so I can complete the equation. Let's try another. This time, what's different about the scale on my axis? So what's different about the scale on my axis this time? Jacob? It's in radians. And so we know that we're going to be working with radians when we go and figure out my period. So let's go ahead and see y equals a times Is this going to be a sine or cosine function? This time, go to the y-axis. My initial value, does that start at an intercept of the center line or a max or min on the center line? Will? It starts at an intercept of the center line. I can see that here. Then on the y-axis, my initial value of this function starts at an intercept of the center line. So let's go ahead and fill that in. My center line looks like it's right there. Awesome. My amplitude A is wave height. That connects the maximum back to the center line or the minimum up to the center line. And next I'll have to figure out the period. And then I can do that by going from key point to key point. So it looks to me like if I start at an intercept, how long does it take to get to another intercept? Well, so long as it's the same kind, it looks like it takes pi units. Does everybody see that? It takes pi units in order to complete one full cycle. Let's try again. Up, down, up. Another pi units. Up, down, up. 3 pi. So it looks like pi units. Great. All right, so this is what we need. First thing, Will told us we start at an intercept of my center line. Therefore, this be a transformed sine or cosine? Jarrett? Sine, thank you. So I know this is going to be sine. Y equals A times sine of Bx, closed angle input, and then plus or minus d. My amplitude is given by my wave height. That's the distance that separates my maximum back to my center line. Take a look at the graph. What's my amplitude for this graph? Megan?
6.
Oh, what distance separates just the max to the center line?
3.
Absolutely. So half that difference between the max and min would be the amplitude 3. Good. So we'll go ahead and fill in the 3. The center line looks like the whole graph is shifted up 3 units, so I'm going to need a plus 3. And the last thing that remains then is my speed factor. So just like we got B before by taking regular period 360 and dividing by observed, we'll do the same thing this time, but do it with radians. Let's try. So I know my value of B is given by regular period, not 360 degrees, because my axis was in radians. I'll say 2 pi radians. Divided by observed period, it looks like it took pi units to complete one full cycle. So 2 pi divided by 1 pi equals 2. So my value of B is 2. And I get y equals 3 sine of 2x plus 3. We're going to continue practicing with radian measure as we work to make a connection, right, between my original parent function, sine of x or cosine of x, and the newly transformed graph. But first, let's go ahead and start with the equation and then generate the graph. This time we get to make our scale, right? We get to make our scale based on the period and then breaking up into quarter period increments. So let's take a look at that. We're going to state the center line, amplitude, and period of y equals 2 cosine of quantity 1/3 x, closed angle minus 1. So first things first, let's do the center line. My center line is gained by looking at the value of d. So what's the equation of my center line here? Ian? Y equals -1. Awesome. So my center line is y equals -1. Let's do our amplitude in blue. My amplitude in blue. Everybody look at my equation. Pick out the amplitude based on that equation and share with the class when I call on you. Mark? The amplitude, right? The amplitude is the absolute value of A.
Oh, okay.
So what would it be in this equation? 2, absolutely. Good. So the absolute value of 2 is 2. That's my wave height. It's the difference that separates my max back to the center line. Or from my center line down to my min. It's 2 units. Good. Thank you. I'm going to go ahead and underline that. And lastly, we'll go ahead and figure out the period. To get my period, I'll do a calculation. My period is gained by taking my normal period, in the 360 degrees or 2 pi radians, whichever we prefer, and dividing it by b, my speed factor. So to get my period, I'm going to go ahead and take 360 degrees, and I'm going to divide it by 1/3, my speed factor. When I do that, I get 360 divided by 1/3 is the same as 360 times 3, so I get, what, 1,080? 1,080 degrees. Raise your hand if you had 1,080 degrees for the period. Did anybody get that far with the period with B? Good. Now I'll go ahead and break that up into quarter period increments so I can label my scale. So I'm going to do a quarter of my period so that I can figure out a good scale for my axis. I know that a key feature on my sine wave occurs every quarter period. Max, intercept, min, intercept, max, intercept, min, intercept. So figuring out the quarter period will make it easier to graph. So I go ahead and do that, and yikes. 540, so 270, so 270, 270? All right, let's go ahead and label my axis now based on this information. So a quarter period would be 270. Therefore, if I go by 270 for each tick mark, 540. I'll end up at 1080. So that's 7, 8, 10. Awesome. And I'll do the same in the negative direction. So it looks like negative 540 would be 2 tick marks and negative 1080. Awesome. It looks like we can go by ones on the y-axis. And the first thing first, I like to put in the center line. So everybody, let's put in that center line. No? Yes? Anybody know? All right, let's go ahead and draw in our center line. Y equals negative 1. So we'll draw that in. In relation to my center line, will this cosine graph start at a maximum, a minimum, or at a intercept? So because it's a cosine, am I going to start at a maximum, minimum, or at an intercept of my center line? Blake?
At the maximum.
At a maximum. Since it's a cosine function, it'll start at a max or min. It's a positive cosine, it'll start at a max. In relation to my center line, everybody go to the y-axis. I'm going to go maximum up an amplitude of 2, so I'll go 1, 2, and get the first key point. Everybody go ahead and find that. There's my key point, my initial value, my starting value from the cosine function. Next, every quarter period, I go to another key point, so I'll go max, intercept, min, intercept, max, and it looks like one full period completes in 1080. That's what we calculated, 1080 degrees. Excellent. Extend that pattern to the left, please. Intercept, min, intercept, max, and we'll go ahead and connect it now with a nice smooth cosine curve. In both directions. Awesome. I saw many of you verified with your grapher. Go ahead and raise your hand if you have this picture. So anybody else have this picture? Good with the sine waves, and we're going to do more practice with this today coming right up. Awesome. What questions do you guys have about your Bellwork then? Okay. So let's go ahead and pause the recording. Okay, ladies and gentlemen, let's go ahead and graph one in radians, right? In radians, so that we can become comfortable labeling my scale with something other than degrees. And so consider the sinusoid y equals negative sine of 2x, close angle input, plus 1. Can we state the center line, amplitude, and period before carefully sketching a graph in radians? Absolutely. We'll do the same thing we did earlier, but now we're going to focus on choosing my period to be in radians, labeling my quarter period in radians, and then determining my scale in radians. So here we go. Center line we can gain by considering my equation. My center line, we know, is the value of d. That addition or subtraction outside of my parent function will shift the entire graph up or down d units. So for us, the equation of our center line is y equals positive 1. Let's everybody go ahead and add that to our graph. So y equals positive 1 is our center line. Next, we can go ahead and get the amplitude. The amplitude is the absolute value of A, the multiplier in front of my parent function. In this case, my multiplier is -1. So my amplitude is the absolute value of -1, which is still +1. However, the negative, while it does not affect my amplitude, it does affect my behavior. This function will exhibit the opposite behavior as it goes through that key starting point. It won't be on the way up to a maximum, it'll be on the way down to a minimum, and that's how that negative will manifest itself. So let's go ahead and first do the amplitude. Amplitude is absolute value of A. In this case, absolute value of -1 is +1. Next, we'll go ahead and consider the period. Recall the period of a graph is gained by considering my normal period of the parent function, this time in radians, divided by my speed factor, that value of B, or frequency, of my angle input. So let's go ahead and calculate that. I know my period will be given by normal period is not 360 degrees if we're working in radians. In radians, it'll be 2 pi radians divided by, and my speed factor was 2. And so to calculate my period, I'll take 2 pi and divide it by my speed factor. Just like we did before, it's just we're using radians for my normal period of 2 pi. Divided by 2, that means my period is pi radians. Before I determine my scale, I want to break that up into quarter period segments, just like before. So a quarter period would be a quarter of pi radians. That's pi over 4 radians. What? Yes, we can label our scale in pi over 4 increments. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. It's just that the 2 pi over 4 will reduce to pi over 2, and the 4 pi over 4 will reduce to pi, and we'll complete one full period in the positive negative direction. So this is going to work out great. Ready? First tick mark, pi over 4 radians. Second tick mark, pi over 2 radians. Third tick mark, 3 pi over 4 radians. And fourth tick mark, pi radians. Notice how that's one full cycle of my graph. That's the period. Let's go ahead and do the same in the negative direction, please. So negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi radians. Does sine start at an intercept of the center line or a max or min? So does sine start at an intercept of the center line or a max or min? Samantha? An intercept, good. The only difference with this function is that because it was negative, I won't be on the way down. I won't be on the way down toward, up towards the maximum. I'll be on the way down towards a minimum. So instead of going up towards the max, like my normal sine function, because this was negative, I'll be down towards a min for my four key points to complete a period. Ready? Intercept, minimum, down 1 unit because the amplitude was 1. Intercept, maximum, intercept. Continue the pattern to the left. Maximum, intercept, minimum, intercept. And we'll go ahead and connect it and get a nice smooth sine wave. I'm going to go ahead and do it in green, so here we go. How do we do? Nice. You're going to have an opportunity to practice with our transformations of our sine waves, both sine and cosine functions. And you're going to do some in radians, and you're going to do some with degrees. We've got a day 11 graphing practice worksheet. You'll be able to work individually or with a partner. But first, let's close it up. Still close. So what effect does the value of A have on my sine wave? What effect does D have on my sine wave? And what effect does the B value have on that sinusoid? Go ahead and put a written response down, and I'll call on you to share with the whole class. what effect each of those parameters have on my sine wave? What effect does A have on my sine wave, right? What does A have to do with my graph? Jacques?
It affects your maximum and minimum value.
Absolutely. A is the distance that separates my maximum back to the center line, or from my center line down to my minimum. And so the absolute value of A is my amplitude. A gives me the distance from the max or min points back to the center line. Awesome. What effect does D have on my graph, right? What does D do? Hans?
What's this one?
D is the equation of the center line. It moves the entire graph up or down D units. And so D gives me the equation of the center line. D is the center line. And it moves the graph up or down D units. And lastly, what effect does the B value have on my function? So what does B have to do with anything? What does B do? Rachel?
It affects the speed and the period.
Absolutely. B affects the speed and the period. So B is the frequency. Of the given sinusoid in comparison to the parent function, right? B is the frequency. To get the period, I simply take the normal period, 360 degrees or 2 pi radians, and divide it by the value of B. And so I'm going to go ahead and call it the normal period divided by B. That will give me the period of the new graph. You're going to have a chance to practice this now individually or with a classmate. But first, I want to make sure everybody understands the assignment for the day. Day 11 graphing worksheet. Everybody take a look at the back whiteboard. Those 3 sheets on the bottom, are an answer key, and these 3 sheets on the bottom on the side whiteboard are answer keys as well. You've got a nice chunk of time and should be able to finish this if you work diligently. Thanks in advance for using this for advanced algebra time. I'm going to go ahead and stop the recording and upload it to our Moodle site.